Okay, this video is on concentration and molarity. So we're going to talk about what that is in chemistry. Real, simple stuff here, but we want to go over a couple of definitions. First of all, a solution is a homogeneous mixture. That means it looks all the same throughout. So if you've got a glass of iced tea, that'd be a homogeneous mixture. It's got water in it, it's got the tea in it, possibly sugar, maybe some lemon juice, whatever you've put in there, but it's all brown. It all looks the same. It's all liquid usually, not counting putting like a lemon in there or something. So homogeneous mixture. Okay. The solvent is the part of the solution that is doing the actual dissolving. Okay. So if you have the iced tea, the solvent would be water. Okay. In that case. The solutes, and there's multiple of them usually in a solution, or there can be, that would be the substance or substances that are being dissolved. Okay. So here we have a solution that we are looking at, and we've got what is known as copper chloride. It's CuCl2, copper 2 chloride. That's a solid blue crystal ionic compound. We've got water as the solvent, and by the way, water is known as the universal solvent because it dissolves so many different things. So with those two together, we get the solution, and you see it's a blue color. It's homogeneous. Again, it looks all the same throughout. Okay. Another topic that comes up in this is usually something known as a saturated solution, and a saturated solution has the maximum amount of solute in it. An unsaturated solution does not. So there's a limit to how much solute you can put into a solution. There's a limit of how much salt I can put into water and get it to dissolve. At some point, there's going to be too much and it won't dissolve at all. The solution process is shown here. You can see the water molecule, which looks like this, and we've got our salt crystal here. And salt that we know as salt is sodium chloride, which is NaCl. Water molecules are polar, which we've talked about. They have a positive side where the hydrogens are and a negative side where the oxygens are. And that's due to oxygen being more electronegative. Sodium chloride is also ionic, which means it's really charged up. So you've got the positive sodiums and the negative chlorines. So the water, the hydrogens will come in and pull the chloride ions away. And it's because they have opposite charges. Hydrogens is slightly positive. The chloride is really negative. And that gets them to just yank those guys out. Consequently, you can also get the oxygens to pull the sodium ions out of there. And so you'll have those guys splitting them apart. Keeps doing it until there's so little left together that you can't see it anymore. And that's when it's dissolved in there. Let's talk about concentration. Concentration is the amount of solute dissolved in a given amount of solution. So the more solute that we put in there, the more grams of solute or moles of solute in there, the more concentrated it is. Okay, so a dilute solution has a really small amount of solute and a lot of solvent. And again, water is usually our solvent. If you have a really concentrated solution, again, that is a large amount of solute. These terms are relative, and what one person might consider concentrated, another person might think, well, I think that's dilute. And this really works with coffee. I like coffee that's very, what we would say, strong. We really want to say it's really concentrated with coffee. It's that dark, really strong taste. My wife drinks that and thinks it's way too concentrated. I drink it and think it's just right. Somebody else might come along and drink my coffee and think that's not concentrated enough. And so it's really like up to the person in that case. So we've got to come up with a way to put numbers to it so that we're all speaking the same language. And numbers usually get us all speaking the same language. Before we do that, what I want you guys to do is pause the video and try to answer these questions. The first thing it says is consider a Coca-Cola. So we've got the Coca-Cola soda here. First question is, what is the solvent? Okay, what's doing the dissolving in the Coke? And really the solvent is, what do we have the most of in there? Okay, it's really another way to look at it. And it says list 3 solutes that are in a Coke. So come up with 3 things that are dissolved into that Coke that you would see either on the label or you can just tell because you've had one before. So you can pause the video, answer those, and then we'll go over it. Okay, so you've had a chance to do that. Let's talk about the solvent first in a Coke. The solvent is H2O. Water is the solvent in most, if not all, beverages. Okay, it's in everything. It's in milk, it's in orange juice, it's in sodas, it's in wine, it's in beer. I mean, you name it, it's water is the solvent. Okay, so that one you should really never miss. Okay, as far as solutes in a Coke, you may have come up with a few of these, or you may not have, and you may have come up with some that I didn't think of. One for sure is sugar, which is sucrose, or in the form of high fructose corn syrup. You know, it really depends on the soda and the Coke. We'd have to look at the label, but some kind of sugar is in there. Some of you may have come up with caffeine that is dissolved in the water. Caffeine dissolves in water pretty easily. Okay, we have acids in there. One of them is phosphoric in a Coca-Cola. If you look on a label. Some of the various food colorings that are in there. You get that brownish color. And there's many others, but those are some of the big ones. There's a really big one too. You may have said the solvent was carbonated water. Really, the solvent is the water. Carbon dioxide is what makes it carbonated water. So CO2 or carbon dioxide is also dissolved in that Coke. Now, gases dissolved in liquids. When you dissolve a gas in a liquid like that, they like and prefer low temperatures. Gases prefer low temperatures to stay dissolved. Solids prefer higher temperatures to stay dissolved. So if you want to get more sugar into a soda, you can heat it up and it will allow you to dissolve it not only faster, but put more in. With gases, it's the opposite. Gases like cold temperatures to stay in there. So if you want your soda to go flatter faster, open it, drink some, and then leave it out. If you want to keep the gas in there, put it back in the fridge until you're ready to drink it again. Okay, let's look at a couple of food labels here. These are for 80 proof vodka. You'll notice that we measure concentration with most beverages in percent. So we have 40% alcohol in 80 proof vodka, and wine is about 14%. They're pretty close on the calories, but the serving size for wine is bigger. Okay, it's like 4 times bigger, maybe a little bit less than that. So the big difference between these two is really the 3 grams of carbs that are in wine, whereas the vodka is getting most of its energy from the alcohol itself, which is why the calories are high in it for a small serving. But again, that's how we measure concentration in our everyday lives. In chemistry, we use something a little bit different that we're going to talk about. And this is how we measure concentration in chemistry. So we use the term molarity to express concentration, and it says quantitatively, meaning with numbers. We talked about coffee. If it's strong or weak, that's open to opinion. When you start putting numbers to things, the opinions go out and data comes in. And so we want that kind of data when we're doing chemistry. So the number of moles of solute in 1 liter of solution is what we're talking about. And again, a solution is a combination of the solute and the solvent. So let's look at an example here. And let's just say that we have, let me make a water solution here that is 200 milliliters in volume. So we have this going here. This is not my best artwork. Boy, I even went outside the flask on that one. Okay, so we've got, imagine that curve's not on the top either, but we've got this flask. Then let's say that we are going to put in some particles in here, and I'm just going to draw simple particles here for this. So we have these guys in there. Again, not my best art, but let's say that each one of these dots represents 1 mole of particles. Okay. So if I look at this, we really have 4 of them. So it'd be 4 moles in 200 milliliters. Now, 200 milliliters, if you do a little dimensional analysis, and you know that 1 liter is 1,000 milliliters, milli means 1,000th. It means smaller than 1,000. So if I take 200 times 1 divided by 1,000, I get 0.2 liters or so. So in this case, we have 4 moles divided by 0.2. And if you do that in a calculator, you should get 8 when you do that. I'm an idiot. You should get 20. Okay, so I'm not going back and starting this video over. So just know that math is not my strong suit and not my best subject. So do it in a calculator I don't know what I was thinking. Okay, so 4 divided by 0.2, let's go back to that. So that would be 20 moles per liter. Okay, now in chemistry, we don't usually write it in moles per liter. We would just write 20 with a capital M, and we would say this is 20 molar solution. Molar like the tooth, okay? But we really mean moles per liter when we say molar, okay? Now, if we took and added more into there and bumped it up to 6 moles per 0.2 liters, and this time I'm using a calculator, we would get 30 molar, whatever the substance is, concentration for that solution. Okay, so the more particles that are in there, the higher the concentration. We already know that, okay? But we're just putting numbers to it now. So let's look at the equation that we use for this, because there is an equation for everything in chemistry. There's 2 ways to get this done. You can use algebra, okay? And that's the equation at the top here. If you don't like algebra, don't use algebra, okay? Forget the algebra, we have a triangle equation that we can use, okay? And we've used triangle equations in here before, but when you see the symbol capital M with a number in front of it, it is read as molar. So 3 capital M, it's really 3 moles per liter. We would say 3 molar. That solution is 3 molar, okay? So we're gonna look at how to use the triangle equation, especially for today. If you're good at algebra, you'd probably be able to do this without my video. So, we'll show it both ways, but we want you guys to, do it the easy way for now, and then we'll worry about the algebra later. Okay. So let's say that in this container, we have a 2 molar solution of this green stuff. What would happen to the concentration if we turn this thing upside down and poured it out? Well, if we turn it upside down and start pouring it out, we would notice that it's still 2 molar. The concentration doesn't change just because you pour some of it out. Okay, and that's definitely true. Pouring out something doesn't change its concentration. I've got a white peach, ginger, bubbly, sparkling water here that's got natural flavors and stuff in it. And it's got carbon dioxide. If I pour this out and then drink it again, it still tastes the same, because the concentration doesn't change when you pour something out. It stays the same. Same thing with coffee or any beverage you drink. So if I wanted the concentration of the CO2 in here to change, I would leave it open and just leave it out, because you guys know the bubbles will come out of there and eventually it goes flat. Same thing with other solutions. If I have a solution of salt water, if I want the concentration to go up, I can let it sit out, because the water will evaporate out. The salt stays. And if the salt stays and the water solvent leaves, concentration is going to go up, okay? So you just have to think a little bit about those. Let's look at an example problem. So it says a solution contains 2 moles of NaCl, that's sodium chloride salt, in 2 liters of solution. And it says, what is the molarity? So you'll notice that I covered up the capital M, the molarity, because that's what it's asking for. So whatever it's asking for, cover it, okay? Notice what's left in the triangle, and notice that there's a line here. This line means to divide. So really what we're saying is molarity equals moles over liters. Okay, and we can see that in the triangle there. Okay, so that's the first thing you want to do, cover up what it is you're looking for. Okay, so we have this, if molarity equals moles over liters. And so then I just plug my numbers in. So you'll see I took my 2 moles, which is on the top, where you can see it here. Took my 2 liters, which is the volume, put that on the bottom. 2 divided by 2, most of you guys can do that without a calculator, and that is 1 mole per liter. Also, we usually just put the capital M and say that's 1 molar. Okay, probably the easiest math you'll do this year would be one like this. Okay. All right. So what I want you to do with this now is pause it and try this out. So the question is, how many moles of solute are in 2 liters of a 0.5 molar solution? So go ahead and pause the video, and then I will go over how to solve this one. Okay. So first of all, what I do, I know what I have liters. So I'm going to make a note of that. This is my liters. It already says it. And I have my capital M here, and it's asking for moles. So it's asking for this. Okay. It's asking for that, cover it up. Now, in this situation, M is next to the L, which means multiply. So it's going to be this times this. Okay. So because they're next to each other, we're going to multiply those guys. So let's look at the solution here. I'll just do it on here. We're going to put moles equals M times L. Our M is 0.5 and our L is 2 liters. And if you do 0.5 times 2, you should get moles equaling 1. Okay, so we have 1 mole of solute in there based on that. Okay, that's how you set that problem up. On the next slide, I just have it typed up so you can see it a little bit better. Now, if you like the algebra, this is our general starting equation. And what we need to do is get the L to the other side if we're going to do it the algebra way. So it'd be times L over 1. This would be times L over 1. Get rid of the 1s. You don't need them. Those cancel out, and we get that equation. Okay, you can do it with the triangle and set it up, or you can do it this way. When I do the math again, this is what's going to happen. The 0.5 capital M is actually moles per liter. That's why the liters cancel out, and we get 1 mole. Again, it's the same answer. It's just a different way of showing it. Okay. This one says how many grams of sodium fluoride are in 0.2 liters of a 2 molar sodium fluoride solution. Now, if you want to try it first, go ahead and pause it again. If not, we're going to go over here right now. So you can pause it now if you'd like. Okay, so let's go over this. First of all, grams and moles are cousins. So if you're being asked for grams, if you're being asked for grams, then you're probably looking for moles, usually in a problem, and that's always true. Okay, so we need to cover up moles because that'll get us to grams. So notice that we have M times L. So we have the L here, we have the M there, and so we're going to put those in. So we have moles, again, same setup as last time. We have 2 molar, which is capital. I'm going to write it as moles per liter just to show the canceling, and that's times 0.2 liters, which is up here. And when you guys do this in your, and I always suggest doing it in a calculator just to be sure, but you're going to get 0.4 moles. Okay, so the liters cancel out, and we're left with moles. Okay, so then it says use dimensional analysis to convert it to grams. So if we have 0.4 moles of NaF, it's asking us for grams. And remember, if you're looking for grams, you need to go to your best friend in this class, and that is the periodic table. If you look up sodium and you look up fluorine and add them together, you get 42 grams. Okay, so 1 mole of NaF is 42 grams from the periodic table. We've done this before. It's been a while, so just reviewing that. The moles cancel out. we get the grams for our answer. So it's 0.4 times 42. You're dividing by 1, so that doesn't matter. We get 16.8 grams of NaF. So this is how we can figure out how many grams are in a solution if they give us the molarity and we know how much is in there. And, 0.2 liters is 200 milliliters. It's not a lot, but there's about 16.8 grams of sodium fluoride dissolved in there. Side note that nobody cares about, but sodium fluoride is found in your toothpaste. Now, here's the typed up setup. If you prefer looking at type instead of my handwriting, this is what I did again, but it's there just to show you guys. I like to talk you through it first, and then if you can't read my handwriting, you can just look at this. But again, we're getting about 17 grams of sodium fluoride in that. You can pause that if you need to look at it or write it down. Yeah, let's try practice number 3. Okay, this time it's asking what is the molarity of the solution. Okay, so pause this if you want to try it on your own first, see if you can get it. Great. If not, sit tight for about 2 seconds here and we will get going on it. Okay, so let's look at what we have in this one. We have liters. I see that here. We have grams. Grams and moles are cousins, so we have a way of getting moles. Okay, it's asking for the concentration, which is molarity, which is this guy. I'm going to cover that up. So we need to get grams into moles. So it's the first step, convert grams to moles. So 10 grams NaCl, 1 mole NaCl. And I go to the periodic table, I look up Na, I look up Cl, I add them together. If you guys do that, you get 58.5 grams of sodium chloride. And then I do a little bit of math in my I always use a calculator. You saw what happened when I didn't. It was a disaster. And I get about 0.171 moles of NaCl. Okay, so now I've got this. I already had the liters. All I have to do now is divide those guys because molarity is moles divided by liters. So I do this, put in 0.1 liter, divide the 0.171 by the 0.1, and I get 1.71 moles per liter, which I'm just going to write as capital M. Okay, so that's another type of question you might see. They give you the grams, they're asking what is the concentration. Okay, and whenever you're working on problems, go back to these notes or look at this video again and use it to help guide you through those questions in homework. Okay, practice really helps on these. If you don't like my handwriting, here is the typed up version that I did for this so you can see it. And those are the 3 basic types of problems you'll get with molarity. That's what a solution is. Solute plus solvent makes solution. Concentration, if it's high, it has a lot of solute. If it's low, we call it dilute. And then there's math that we can do to figure out how concentrated something is, okay, or how much solute's in there, things like that. So hope this helped. Let me know if you guys need any further help. You know how to get a hold of me. You can leave comments or you can message me. Okay, talk to you guys later.